Okay, guys, we had the quiz on factoring and solving. Let's take a look at some of this stuff. Okay, here's the thing. Greatest common factor. That is the first thing you do if it works, okay? Then you look at all the other things you had. So we had greatest common factor. Try that first. And then we branch out. What do we see next? It's either going to be difference of squares, or it's going to be a quadratic. We're looking for two numbers that multiply to something, add to something, or it's going to be grouping. That's all there is, okay? Okay, difference of squares. You got two things with a minus in between. Quadratic, you've got three things. Grouping, you got four things. That's all that can happen. So you have to be real solid on the flow of this. When I look at this, there's no greatest common factors. Two things, perfect squares, separated by a minus sign. There is no good excuse for missing this one. There is a formula. That's 5n minus 1, 5n plus 1. Okay, look at the next one. Okay, it looks confusing. Let's go back and ask myself, is there a greatest common factor? It looks like there is. It looks like there is an x squared in common. So if I factor that, I get 7x squared, because when I multiply those, I get 7x to the fourth, and then minus 44. If I factor x squared out, I'm left with an x minus 35. Okay. Now, what are you left with? This looks like a quadratic. Okay. How can I factor that? That will factor if I can find two numbers that multiply to give me whatever 7 times negative 35 is. So 7 times negative 35, you've got a calculator on this. So 7 times 35, that's negative 245. And those numbers are going to have to add to give me a negative 44. Okay, negative 245. I don't know a whole lot about that, but I know it's 1 and 245. Okay. I can divide this by 5. So 245 divided by 5 is 49. So this is 5 and 49. Even though the number was big, I can see right out of the bat that the difference between 49 and 5 is 44. So if the 49 is negative and the 5 is positive, that's going to be my factorization. So this turns into x squared, 7x squared, plus 5x, minus 49x, minus 35. Now it's factored by grouping. X squared. The first two terms have an x in common. 7x plus 5 minus, and it looks like I can factor a 7 out, 7x plus 5. So this final answer is going to be x squared, x minus 7, 7x plus 5. Okay, that's the final factorization of this guy. So again, it was greatest common factor, then it turned into a trinomial. Here, I don't see a greatest common factor. They're not divisible by 2, they're not divisible by 3. I see four things. The only method I learned for four things is grouping. So what do the first two things have in common? It looks like 8x squared, and then I'm left with 3x plus 2. Copy down the minus sign. The 15 and the 10, it looks like they have a 5 in common. That leaves me with 3x plus 2. So this is 8x squared minus 5, 3x plus 2. Now ask myself, is that the difference of two squares? It is not. The x squared is a perfect square, but 8 and 5 are not. I'm done. This is my final answer. Looking over here, trinomial. Okay, how do I factor this? I need two numbers that multiply to give me 5 times negative 4, so negative 20, and add to give me an 8. What numbers can do that? Okay, so multiply to 20 and add to 8. So factors of 20 are just what, 1 and 20, 2 and 10, 4 and 5. The only way I can get an 8 is with a 2 and a 10. So it looks like if I have a negative 2 and a positive 10, that's going to multiply to negative 20, add to 8. So this is 5 n squared minus 2n plus 10n minus 4. Factor by grouping. So this is n, 5n minus 2 plus 2. 5n minus 2. Answer is n plus 2. 5n minus 2, and you're done. Next problem. What's the first thing you want to do if it ever works? Greatest common factor. Okay, well, it looks like these things have a 3x in common. So factor out a 3x, and I'm left with 2x squared minus 7x plus 3. That is a trinomial, quadratic. If that factors, I am in the search for two numbers that multiply to 6 and add to negative 7. The only factors of 6 are 1 and 6, 2 and 3. The only way those can combine to give us 7 is the 1 and the 6. So if I had a negative 1 and a negative 6, those will multiply to 6 and add to negative 7. So this answer is 3x, and then 2x squared minus x minus 6x plus 3. Factor by grouping. So this is 3x. Factor out an x, 2x minus 1, copy down the minus sign. And then it looks like I factor out a 3, 2x minus 1. So this final answer is 3x, x minus 3, 2x minus 1. And you're done. The next one, 4 terms. The only thing I know is factor by grouping. Look at the first 2 terms. What do they have in common? It looks like 2y squared. And I'm left with 3y plus 5. Look at the next 2 terms. Looks like they have a 5 in common. 3y plus 5. And this final answer is 2y squared plus 5. 3y plus 5, and we're done. So that's all the factoring. Next we move into solve. There's not a whole lot of difference between solve and factoring. Factoring is a method you use to solve. So in this case, let's look at the next one here to figure out what we will do for this. So in order to do this, I'm going to set it equal to 0. 2x squared minus 3x plus 9 minus 29 equals 0. 2x squared minus 3x minus 20 equals 0. Now this is a quadratic. I need 2 numbers that multiply to negative 40 and add to negative 3. What are the factors of 40? It's 1 and 40, 2 and 20, 4 and 10. I don't see any way to add those to get a negative 3 yet. 5 and 8. That's going to be it. The difference between those is 3. So if I had a positive 5 and a negative 8, those will multiply to negative 40, add to negative 3. This is 2x squared plus 5x minus 8x minus 20 equals 0. Factor by grouping. So x, 2x plus 5 minus, looks like a factor of 4 out here, 2x plus 5 equals 0. Final answer, x minus 4. Well, almost final answer, 2x plus 5 equals 0. Set each factor equal to 0. When x minus 4 equals 0, that means that x equals 4. When 2x plus 5 equals 0, that means that 2x equals negative 5. That means that x equals negative 5 over 2. Those are your 2 answers. Look at the next one. A lot of people had trouble with this, but what's the first plan of attack? Is there a greatest common factor? It is w. W squared minus 25 equals 0. What's in parentheses? That looks like the difference of 2 squares. This is w. W minus 5, w plus 5 equals 0. I'm completely factored. Set each factor equal to 0, and I get w equals 0, If w minus 5 equals 0, I get w equals 5. And if w plus 5 equals 0, I get w equals minus 5. And I'm done. Let's look at the next one. A lot of people struggle with this one. First off, what are the restrictions? I can never divide by 0. So m plus 3, no matter what it is, it will never be 0. So m can never be negative 3. Likewise, m can never be 2. These are my restrictions. Now I have to multiply everything you see by m minus 2, m plus 3. So I'm going to write it out so I don't make mistakes. M minus 2, m plus 3 gets multiplied by 5 over m plus 3 equal m minus 2, m plus 3 gets multiplied by 4 over m minus 2 plus m minus 2 over m plus 3 gets multiplied by 12m over m minus 2, m plus 3. A lot of people don't want to write all of this out, but if you will do this, you can keep from making mistakes. The whole goal of doing this is every denominator should cancel when you do this. And I get a whole lot simpler equation. I get 5 times m minus 2 equal 4 times m plus 3 plus 12m. Now it's just a matter of, can you simplify? 5m minus 10 equal 4m plus 12 plus 12m. 5, and take as many steps as you need. 5m minus 10 equal what? 16m plus 12. I want to get the m's on one side and the numbers on the other. So let's subtract 5m from both sides. And I get negative 10 equal 11m plus 12. Now I subtract 12 from both sides. And I get negative 22 equal 11m. I divide both sides by 11. I get negative 2 equal m. Does that violate my exclusion? No, m cannot be 2. It's okay to be negative 2. Okay? So that's the way that one worked out. Let's see if I need to make this a little bit smaller so I have room to work. Okay, the next one here, my restriction, n plus 2, cannot be 0. N cannot be negative 2. Okay. This entire equation, everything has to be multiplied by n plus 2. If you're having trouble, write out each step. You're going to have n plus 2. It gets multiplied by n over n plus 2. What's the next thing? Plus. I've got that n. It has to be multiplied by n plus 2. Equal 5n plus 8 over n plus 2. That has to be multiplied by n plus 2. So what I did here, everything got multiplied by n plus 2. The reason I did that is so that everything simplifies, and what am I left with? I'm left with n plus n plus 2 equal 5n plus 8. Now I've got n plus n squared plus 2n equal 5n plus 8. I've got n squared plus 3n equal 5n plus 8. I want this to be equal to 0. So when I do all of that, I get n squared minus 2n minus 8 equals 0. I will factor this. I need two numbers. So two numbers. that multiply to negative 8 and add to negative 2. Those numbers are negative 4 and 2. This is n minus 4. N plus 2 equals 0, which tells me that n is equal to 4 or negative 2. But I knew from the very beginning of this problem that n cannot be negative 2. So there is only one answer here, n equal 4. Okay. Next one, I've got cube roots. My goal is that cube root of w minus 5 needs to get isolated. Okay, so what has to happen, my goal is to get that all by itself. Well, what is keeping it from being by itself? It's multiplied by negative 11. To undo multiplication, I've got to divide both sides by negative 11. Some people subtracted negative 11. That doesn't work, okay? So what I end up here, cube root of w minus 5 equal, when a 22 divided by negative 11 is negative 2. Now I've got the cube root is isolated. I cube both sides of this equation. That gives me w minus 5 equal negative 2. Negative 2 needs to get cubed. What is negative 2 cubed? That's negative 2 times negative 2 times negative 2. That's negative 8. So w minus 5 equal negative 8. Add 5 to both sides, and you get w equal negative 3. Okay. Number 10. Okay. On number 10. To solve this one, you have to square both sides. So you get 6x plus 10 on the left equal 2x plus 2 squared. Okay. If you think this is 4x plus 4, you are wrong and you're going to really struggle. Okay. That's not how you square that. So I'm going to erase that. That needs to get out of your memory. So we've got 6x plus 10 equal, so it's 2x plus 2 squared. So that's 2x plus 2 times 2x plus 2. How do I do that? This is 6x plus 10 equal. So when I FOIL that, I get 4x squared plus 4x plus 4x plus 4. Now it's just a matter of getting this thing equal to 0. So I've got 6x plus 10 equal 4x squared plus 8x plus 4. If I subtract 6x and subtract 10 from both sides, I get 0 equal 4x squared plus 2x minus 6. Now it's just a matter of factoring this. 0 equal, I can factor out a 2. 2x squared plus x minus 3. This demands that I find two numbers that multiply to negative 6 and add to 1. Those numbers are 3 and negative 2. So 0 equal 2. 2x squared plus 3x minus 2x minus 3. So 0 equal 2. Factor by grouping. This is x. 2x plus 3 minus 2x plus 3. So this gives me 0 equal 2. X minus 1, 2x plus 3. This tells me when I set each factor equal to 0. X minus 1 equals 0 means that x equals 1. 2x plus 3 equals 0 tells me that x equals negative 3 halves. I'm not done with that until I check both of those answers. So I've got to check these answers. So let's just check with, it was the square root of 6x plus 10 equal 2x plus 2. let's check x equal -3/2. So the square root of 6 times -3/2 plus 10 equal 2 times -3/2 plus 2. So 6 divided by 2 is 3. So this is -9. This is -9 plus 10. So this is the square root of -9 plus 10. That's the square root of 1. This side is 1. Okay, so on the left side I get 1 equal. Okay, over here this is just 2 divided by 2. This is -3 plus 2. This is -1. That is not a true statement. So this is not a solution. You check this one, it will be the only solution. Let's check it. 6 times 1 is 6. 6 plus 10 is 16. Square root of 16 is 4. 2 times 1 is 2. 2 plus 2 is 4. 4 equals 4. So that's your only solution. And the bonus, real quick. This one, it's grouped in parentheses, so you can figure out, treat it as two separate problems. Looks like an x squared is in common here. So let me make this a little bit bigger. So if I factor out an x squared, I get 2x squared plus 3x plus 1. And then if I factor out a -4 here, I get 2x squared plus 3x plus 1 equals 0. This is x squared minus 4 times 2x squared plus 3x plus 1 equals 0. Well, I know what that one is. That's x minus 2, x plus 2 times 2x squared plus 3x plus 1 equals 0. Now, can I factor this? Let's move off to the side and see if we can do that. So 2x squared plus 3x plus 1. I need two numbers that multiply to 2 and add to 3. That's pretty easy, 1 and 2. So this is 2x squared plus x plus 2x plus 1, and then factor by grouping. 2x plus 1 plus 2x plus 1. This is x plus 1, 2x plus 1. So you can go from this step to, you've got x minus 2, x plus 2. This factors to what we just found here. X plus 1, 2x plus 1 equals 0. If I set each of these equal to 0, I get x equal 2, -2, -1, -1/2. So this is a tough one. But the key was, what did this thing do? For the first step, I had to use GCF to get these first steps. So GCF, and then this was, that's the difference of squares. This is factoring a quadratic, and this is grouping. It used every factoring method that we have. So pretty complicated, but an illustration of all the different factoring methods. Okay?